Okay, now I'm going to do some example questions. So if you, it's recommended you to do this question with me. So if you have a pen, well, please grab a pen and paper, read the question, let's do it together. So in this question here, um, we have a graph, and we need to learn how to read it, and basically how to use the graph to find all the details of the motion. Now we have something that moves in a straight line, so that object is going to move just forward and backwards, to the right or to the left. And we have a position and a time graph. So this is basically a displacement and a time graph. Okay. Now, if we if we read this graph briefly, okay, what we can say is now initially it starts from zero. Initially, I have something start from zero. It's moved to the positive direction. Let's make this positive, so it's the object move to the right. Okay. Then stop for a few seconds. Okay. Then it moving back, it's dropping down. So then it comes back, okay, on a straight line and passing the initial starting point. So it's move back somewhere. Then it moves in the positive direction again. Okay. So, but it doesn't move at a constant speed because you say the gradient is different. So anyway, uh, yep, we have a brief look through of the graph, and let's do the questions. Now, question A, we need to find is stationary. Stationary means doesn't move. Okay, so from the graph, I can say it starts from the initial point and move to 80 meters above further, and it stays there for 20 seconds. So the section, uh, what I can say is from t equals to 20 seconds to t equals to 40 seconds, or yep, or yep, when t is greater than or some write down something like this, it is stationary. Okay. Or method people, you can write down something. Yep, you can write down something like this. Don't be afraid to use mathematical symbols answering those questions. There are three ways of answering it. Either of them will be fine. Question B. We need to find the section that the interval was traveling north. Okay. Yep. Okay. When it's positive, it's north. It start moves north. Okay. So when it's traveling to the north, what I can say is, okay, initially from 0 to 20 seconds, it's traveling to the north. Okay. It stays there for a while, then it travels back because its position is decreasing. Then after this point, it's traveling to the north again. Okay. So the answer would be, okay, it's traveling at north when the time is from 0 seconds to 20 seconds. Okay. And also when the time is greater, it's after 60 seconds. Okay. When the time is greater than 60 seconds, he travels north. Now, question C. about that. Just give me a second. Yep, something like that. Okay. Yep. Question C, actually. Sorry, just let me. Sorry. Ask me. Okay. At what instant the skateboard rider first move backwards at starting time? So it's obvious. Right? Travels north, stay well, move back at t equals 40 seconds. Now, uh, question D. Okay. So it asks for the displacement during the 80-second interval. So at t equals to 80, at t equals to 80, we can read its position is 20 meters to the north. So it starts from 0 and it's 20, so its displacement is 20 meters north. So then the question asks, what's the distance during the 80 interval? So this, well, for the distance, we need to basically travel, write it down. So initially, for the first 20 seconds, it traveled from 0 to 80 meters. Okay. Then it stayed there. Then it traveled back. Okay. From 80 meters to minus 40 meters. Thus, he traveled 120 meters. So from 80 to 0, then from 0 to minus 40. So that's he traveled 120 meters. Then he traveled 40 meters with another 20 meters. Okay. So add them up, it will be 260 meters. So for question F, we need to find the section of the interval that the 8 speeding up. Okay, now, okay, so remember when we talk about speed, okay, we have a displacement and time graph. Okay, we can find the velocity or the speed by finding the gradient of this graph. So if you look at this graph for the first 20 seconds, the speed is constant. The gradient of this line, the gradient of this linear line is zero. Well, it's constant, right? Because its position is increasing at the same rate. Okay? The rate of change is constant. That means it's not speeding up. Then it's stationary, so it doesn't speeding up. Then for this part, the speed is basically again it's constant because we have a linear relationship. We have a straight line, okay, in the position and time graph. Okay, the rate of change of this is constant. Then from here, from 60 to 70, we have a curved line. Okay? This means the speed is the rate of change of position time is different. So my answer will be from 60 seconds to when time is between 60 seconds and 70 seconds. Okay, so this is the part it speeds up. Okay. The trick of to do this question is we talk about the speed and we have a displacement and time graph. The speed is the gradient of this graph, so just look, use your mathematical skills, just look at the gradient. Okay. In this part, the gradient must be increasing. You say the rate of change at this position is much higher than the rate of change of at this position. So from 60 to 70, it is speeding up, it is accelerating. Okay. Now let's move to question J. We need to find the interval the skateboard was slowing down. Okay, so as what we say, initially it's traveling at constant speed. The gradient is constant. It doesn't speed up or doesn't slows down. Then it's stationary. Then it doesn't speed up or doesn't speed down. Okay. So from this part here, okay, the answer is from between 70 seconds to 80 seconds. Okay. Now, during this interval, the rate of change, okay, remember the gradient is the speed. Okay, the speed is very high at 70 seconds. Then afterwards is low. The gradient becomes lower, so that indicates the speed changes and is slowing down. Okay, question H. Question H asks me the average speed during the entire 80 seconds interval. Okay, so the average speed, okay, is basically the total distance traveled. Okay. Remember, it's speed, not velocity. Okay. The total distance traveled, which is 80, okay, plus, which is 80 plus another 80 plus 40, okay, plus another 40 plus 20, the distance, divided by the time. Okay, the total distance divided by the total time. Okay. So if you do it, it will be 260. Okay, it will be 260 divided by 80. So it's going to be 3.25 meters per second. Okay. We have meters on the top, we have seconds there. That's the average speed. Question I, okay, we need to find the velocity. Okay. So the velocity is basically we need to find the velocity, like, during the first 80 seconds. The velocity is the displacement. Okay. The average velocity is the displacement divided by the time. Okay. So during the first 80 seconds, remember this is the average velocity. Don't be confused by what they're asking. This is the average velocity. Now, the average velocity will be the total displacement, which is 20 meters divided by 80 seconds, which is 0.25 meter per second north. Okay. So during the entire trip, he is traveling 0.25 meters per second in the direction of north. The last question, we need to estimate the velocity of the skateboarder at 65 seconds. Okay, 65 will be somewhere there. Okay. Remember, in previous question here, we finding the average velocity. In here, okay, we finding the instantaneous velocity. So when the time is 65 seconds, at that instant, what is its velocity? Okay. We have its position graph here. What we need to do is we need to find the gradient. Okay. So it says estimate, so it doesn't have to be very accurate. But what we can do is I can show you. Let's enlarge the graph. So what we can do is we need to find the gradient, okay, at this point. Okay. So what we do is we draw a straight line. Okay. We draw something like this, a straight line. Okay. And we find its gradient. Okay. The horizontal distance is 10 seconds. No, okay, sorry, I need to. It's 10 seconds. Okay. The vertical, if we have a look, the vertical will be that's 1, 2, 3, 4, 5. The vertical will be 16 meters. Okay. So the horizontal this part 10 seconds, the vertical this part will be 16 meters. So if I try to find the gradient will be rise over run, how much is the vertical divided by the horizontal? Okay. So the gradient, which is the velocity, okay, will be the vertical. Okay, it's always the vertical divided for gradient. It's always the vertical divided by the horizontal. Okay. 16 divided by 10, which is 1.6 meters per second north. Yep. So that's it. Okay. Yep.